हा नको थांब जरा, मी काहीतरी वेगळंच लावलं होतं बहुतेक. हा कारण दिसायला लागले आता. हॅलो.
हाँ हेलो.
थोड़ी देर के बाद.
येते का आवाज?
हॅलो.
आवाज येते का?
हा खूप हळू येतोय.
खूप हळू येतोय. हा मला वाटलं तो लॅपटॉपचा आहे ना, त्यामुळे ओके मी दुसरा लावतो.
हॅलो.
हा हॅलो, एक मिनिट. हा एक मिनिट.
हॅलो सर, मी राजीव पाटील.
गुड इव्हनिंग. नमस्कार.
नमस्कार सर. सर थँक्यू व्हेरी मच तुम्ही ऍक्सेप्ट केल्याबद्दल आमच्या लेक्चर मध्ये यायचं.
थँक्यू सर. वेलकम.
हॅलो.
हॅलो सर. गुड इव्हनिंग.
हा गुड इव्हनिंग. धनंगोड सर.
हा सर.
की तुम्ही ते हे डिसेबल केले ना, पार्टिसिपंट्स अनोटेशन? कारण काल आमचा प्रॉब्लेम झाला सुरुवातीला.
हा हा.
तर तुम्ही जेव्हा शेअर करता ना तुमचं स्लाइड, तेव्हा उजव्या बाजूला शेअरचा स्क्रीन आला की उजव्या बाजूला वरती मोर म्हणून दिसेल तुम्हाला. मोर ते क्लिक केलं तुम्ही की तिथे तुम्हाला डिसेबल पार्टिसिपंट्स अनोटेशन असं येतं बघा.
ओके बघतो. हा सर.
बरोबर. काल लोकांनी फार त्या सुरुवातीला त्रास दिला आम्हाला. शेअर स्क्रीन करा.
डिसेबल पार्टिसिपंट अनोटेशन.
हा एक्झॅक्टली. ते हे करा, डिसेबल करा ते.
हा केलं सर.
ओके. म्हणजे आता काय होतं, आता कोणी हे केलं ना मग स्क्रीनवर नाहीतरी लोक काहीतरी करत राहतात त्याच्यावर.
ते आज मार्क करतात,
एक्झॅक्टली
अंडरलाईन करतात.
हा. आणि ते जो शेअर करतो त्यानेच करायचं असतं.
करेक्ट करेक्ट.
म्हणजे राजीव पंडित कॅनॉट डू दिस. यू हॅव टू डू इट.
हा सर, कारण मला दिसतच नाहीये काही ते.
हा नाही बरोबर. ते स्क्रीन शेअर जो करतो ना त्यालाच करायचं असतं ते.
हो हो,
त्यानेच करायचं असतं. ओके.
आता सर घेऊया सगळ्यांना.
हो घ्या ना. 6:30 व्हायला आले ना.
हो
हो 6:27 झाले.
सर तुम्ही प्रमोद सर, स्क्रीन तुमचा मिनिमाइज करून ठेवलाय म्हणजे ओपन झालाय ना?
ओपन झालाय सर.
हा.
आता दिसलं ना सर स्क्रीन?
हो सर, एकदा दिसलं.
ओके
ओके. मग मी घेतो सर. आपण कसं करूया की शेवटची म्हणजे 8 वाजेपर्यंत आपल्याकडे वेळ आहे.
हो हो.
तर शेवटचे एक 10-15 मिनिटं आपण सर प्रश्नोत्तरांना ठेवूया.
ठीक आहे सर.
हा
राजीव
माझं टॉक सर इंग्लिश मध्ये राहणार. थोडं मध्ये मध्ये जमेल तर मराठी घेतो.
हो सर, काहीच प्रॉब्लेम नाही.
नाही राजीव.
हो.
हा प्रमोद सर चांगलं मराठी बोलतात, तसा काही प्रॉब्लेम नाही.
हो.
पण हा इंग्लिश मराठी बायलिंग्वल होऊ दे त्यांचं. काही
हो होऊ दे, काहीच अडचण नाही सर.
टेक्निकल वर्ड्स थोडं प्रॉब्लेम होणार.
सर टेक्निकल वर्ड आता अजिबातच शोधू नका, अगदी इंग्लिश मध्येच वापरा.
इंग्लिश मध्ये घ्या ते, काही प्रश्न. राजीव घ्यायला हरकत नाही लोकांना.
हो चालेल सर, मी घेतो आता सगळ्यांना.
म्हणजे पार्टिसिपेंट आहेत.
सर सगळ्यांना म्यूट केलेलं आहे. फक्त मी तुमचा इंट्रो दिल्यानंतर तुम्ही अनम्यूट करून लेक्चर द्यायला सुरुवात करा सर. प्रमोद सर.
प्रमोद सर. हॅलो राजीव, तुम्ही
म्यूट केलंय.
हा सर. हा हॅलो. ओके.
सर एक 2-3 मिनिटात चालू करू, लोक येत आहेत. हॅलो, गुड इव्हनिंग. आपण बरोबर 6:35ला सुरुवात करूया. सगळ्यांचं अजून जॉईन होत आहेत, तर त्यामुळे 1-2 मिनिटं आपण वाट बघूया सगळ्यांची. मी सगळ्यांना म्यूट केलेलं आहे, त्यामुळे प्लीज अनम्यूट करू नका.
नो, गॅलेक्सी G6 यामधला कोणतरी. मग आता गॅलेक्सी M31, गॅलेक्सी 6, मग हे आपलं असेल की कुठलाही गॅलेक्सी असू शकेल. अच्छा, नाही 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 नाही. आता पार्टिसिपंट्स लिस्ट इथे हे केलं तर बंद होईल ना वर, क्लोज म्हटलंय ते.
गुड इव्हनिंग ऑल. जीवितातर्फे मी जीविताचा अध्यक्ष राजीव पंडित सगळ्यांचं स्वागत करतो. आपल्या कालपासनं इंटरनॅशनल अर्थ सायन्स वीक म्हणजे जागतिक भूविज्ञान सप्ताहानिमित्त आपण ही व्याख्यानमाला सुरू केलेली आहे. दरवर्षी आपण या निमित्ताने काही ना काहीतरी उपक्रम करत असतो. जगभर ऑक्टोबरच्या दुसऱ्या आठवड्यामध्ये हा सप्ताह साजरा करायचा अशी संकल्पना आहे. या वर्षीचं जी थीम आहे तर ती अर्थ मटेरियल अशी आहे आणि त्याला धरून आपण हा पृथ्वीवरील खडक या विषयावरची ही व्याख्यानमाला करतो आहोत. एकंदर 4 दिवसाची ही व्याख्यानमाला आहे आणि त्यातनं आपण खडक या विषयावरती वेगवेगळ्या अँगलनी बघणार आहोत. त्यातलं आपण काल सुरुवात केली ती डॉक्टर श्रीकांत कारलेकर सरांनी की ज्यांच्या संकल्पनेतनं ह्या व्याख्यानमालेला आपण हा विषय आणखी त्यातले व्याख्याते ठरवले आपण. तर त्यांनी काल आपल्याला खडक या विषयावरती माहिती दिली. मुख्यतः त्यांनी आपल्याला सगळ्यात इम्पॉर्टंट की सह्याद्री आणि महाराष्ट्र हा धरून खडकांचे खूप वेगवेगळ्या प्रकारांविषयी त्यांनी आपल्याला माहिती दिली. त्याच्यात पुढे जाऊन आज आपण बघणार आहोत ते म्हणजे मिनरल्स विषयी आणि यासाठी आपल्याकडनं डायरेक्ट बेळगाववरनं डॉक्टर प्रमोद हनमगोंड सर आलेले आहेत. तर त्यांचे मी जीविधा आणि तुमच्या सर्वांतर्फे स्वागत करतो. वेलकम सर. प्रमोद सर.
हा सर, वेलकम. थँक्यू.
येस, थँक्यू. सरांची ओळख करून द्यायची झाली तर त्यांनी बेळगाव मधलं GSS नावाचं कॉलेज आहे तर ते तिथनं ते आता जिओलॉजी विभागात प्रोफेसर आणखी त्याचे त्या विभागाचे इन्चार्ज म्हणून किंवा हेड ऑफ द डिपार्टमेंट म्हणून काम करतायत. त्यांनी MPhil आणि PhD केलेली आहे. दक्षिण कोकण, कर्नाटक या ठिकाणची ज्या किनाऱ्या समुद्र किनाऱ्यावरच्या पुळण्या असतात तर त्याच्यामध्ये त्यांचं सरांचं स्पेशलायझेशन आहे मुख्यतः. आतापर्यंत त्यांनी जे काम केलेलं आहे भूविज्ञानामध्ये तर त्याच्यासाठी त्यांना अनेक पारितोषिकं मिळालेली आहेत. त्याच्यामधलं काही उल्लेख करायचे झाले तर ACRC त्याच्यातर्फे त्यांना 2 वेळा यंग सायंटिस्ट अवॉर्ड मिळालेला आहे. कर्नाटक राज्य शिक्षणोत्थान प्रतिष्ठान म्हणून आहे तर त्याचं 99 मध्ये एकच मिनिट सॉरी 99 मध्ये त्यांना शिक्षक रत्न पुरस्कार मिळाला. त्यानंतर उत्कृष्ट प्राध्यापक पुरस्कारांनी सरांना सन्मानित केलेलं आहे. ज्ञानश्री उत्कृष्ट शिक्षक पुरस्कार सुद्धा त्यांना मिळाले आहेत. त्यामुळे एक उत्कृष्ट शिक्षक आज आपल्याला लाभलेले आहेत. अनेक संशोधन प्रकल्पात सरांचं काम आहे. आणखीन अनेक PhD च्या विद्यार्थ्यांना सर मार्गदर्शन करतात. राष्ट्रीय आणि आंतरराष्ट्रीय पातळीवर अनेक संशोधन पत्रिकात त्यांचे निबंध आतापर्यंत प्रसिद्ध झालेले आहेत. एन्सायक्लोपीडियामध्येही त्यांनी बऱ्यापैकी ठिकाणी लिखाण केलेलं आहे आणि अनेक वैज्ञानिक संस्था ज्या असतात त्याचे सर सभासद आहेत. तर असे आपण म्हणू की एक रिसर्चर, एक टीचर आणखीन एक संशोधक असे आपल्याला आज सर लाभलेले आहेत. आणखी बेळगाववरून आलेले आहेत तर मला असं वाटतं की त्यांच्या आपण सर्व जे नॉलेज आहे त्याचा आपण फायदा करून घेऊया. आजचा त्यांचा विषय जो आहे तो मिनरल्स हा असणार आहे आणि त्याविषयीची माहिती आपण आज करून घेणार आहोत. सगळ्यांना एक विनंती की आपण 6:30 ते 8 या वेळामध्ये आपलं आजचं लेक्चर असणार आहे. तर शेवटची 15 मिनिटं आपण क्वेश्चन आन्सर साठी ठेवूया. मध्ये कोणी प्रश्न विचारू नका. तसंच मी सगळ्यांना अनम्यूट केलेलं आहे तर कोणी अनम्यूट होऊन करू नका स्वतःला कारण इथे बाकीच्यांना खूप डिस्टर्ब होतो. तर सगळ्यांनी म्यूट ठेवा. आपले हे व्हिडिओ पण बंद ठेवा कारण रेंजचा शेवटपर्यंत प्रॉब्लेम येतो तर त्यामुळे कोणी आपले व्हिडिओ चालू ठेवू नका. ओव्हर टू यू सर. पुढची सर्व सूत्र मी तुमच्याकडे सोपवतो.
थँक्यू सर. स्क्रीन दिसतो ना सर?
हो सर, स्क्रीन दिसतोय, काहीच प्रॉब्लेम नाही.
ओके सर, थँक्यू.
सर फक्त आवाज थोडासा वाढवता येईल का व्हॉल्यूम?
बर, फुल आहे सर.
ओके.
प्रथम मी जीव विविधा संस्था त्यांचे संचालक राजीव पंडित सर आणि कारलेकर सर यांना आभारी आहे. या संदर्भात मला इथं इन्व्हाइट केलेले ऍज अ guest lecture म्हणून. तर I thank you both and all my participants for giving this opportunity to share my whatever little knowledge on minerals. Even though I am a geologist, my specialization is coastal dynamics, but I teach mineralogy, rocks, minerals, paleontology, etc. for BSc students in our college. So let's start with the mineral components of rocks. Yesterday we have heard Karlikar sir about rocks. I hope many of you have understood now what is rock and all. Now, atoms make up elements. Atoms make up elements. Atoms म्हणजे अणु. Elements, छोटे छोटे atoms make up an element. That is, I think, घटक. Okay.
बॉडी नाही म्हणते नाही बॉडी तर नाही ते घरी भाज्या घेऊन जायचं मला.
Okay. So elements, atoms make up elements. Elements combine to form the natural compounds. Okay, elements combine to form the natural compounds. And these compounds, natural compounds and elements combine to form minerals. Okay, I hope you understand. Atoms, smallest element of material, make up elements. Elements combine to form compounds, and these compounds along with elements make up minerals. And all these minerals make up rocks, and all these rocks make up the earth. Now what we'll discuss what is mineral, what is rock, types of rocks. Already we have discussed, Karlikar sir has discussed, so I'll not go into deep about rocks, etc. But just to brush up your yesterday's knowledge, we have, you take up any rock, कुठलाही rock भूमीवरती तुम्ही घेतला, तर you can definitely describe them into three types. Actually, any layman can say that it is a rock, but little knowledge about geology, they can classify these rocks into three groups, main groups. Whichever rock, if you find, they can be classified into three groups. Another one is sedimentary, third one is metamorphic. You take any rock on the surface of the earth, they can be classified into three main groups: igneous, sedimentary, metamorphic. Igneous rocks are made from magma and lava. Okay, volcanic eruptions, magmatic intrusions, etc. They are found in the deep inside the earth as well as on the surface of the earth. Surface of the earth, they are called as volcanic igneous rocks. Deep inside earth, they are called as plutonic igneous rock. And shallow inside the crust, they are called as intermediate rocks or hypabyssal rocks. Depending upon, again, mineralogy and texture, structure, etc., they are further divided into many groups of rocks, igneous rocks. Sedimentary rocks are formed under aqueous media by water, action of water, weathering, erosion, transportation, deposition in a basin, then consolidation, lithification, diagenesis. All these processes make up these sedimentary rocks. Again, sedimentary rocks are classified as mechanical sediments, and they are called as clastic sediments and non-clastic sediments. Clastics are mechanical sediments, non-clastic are evaporate and chemical or biochemical sediments. This is just brushing your knowledge yesterday's. Metamorphic rocks are effect of temperature, pressure, stress in the rock created by plate tectonics, movements in the earth. These are called as tectonic activities. And the pre-existing rocks, either it can be igneous or it can be sedimentary or even metamorphic rocks. If they undergo pressure, temperature, and liquid media, combining the forces act on the rocks, they modify the rock into new rock. That is called as metamorphic rock. And within these three types of rocks, we have different minerals. They form, the processes are different, etc. Okay. So these are the processes inside the earth. Okay, these are tectonic forces. We have convergence, we have divergence, we have transform activities. The first figure, if you see the animation, that is convergence, where two plates move towards each other. One can go inside. If one is softer than the other, the softer one goes inside and it melts inside, and it comes out as a mountain or even volcanoes. Okay, but there can be a force which divide them or drive them out, or divergence. So in that case, the sea floor spreading can be happening, or the land can elongate, or there can be a mid-oceanic ridge which erupts the lava and magma, and there can be transform action. So these are the three important tectonic movements which create rocks, volcanoes, etc. And these are the main factors which create earthquakes also. So let's jump into main topic, mineralogy. It is the branch of geology which deals with study of minerals and their chemistry, physical properties like color, streak, diaphanity, etc. Lots of physical properties are there, and the genesis, how these minerals are originated. That's the branch of geology and is called as mineralogy. Now, a mineral is a naturally occurring inorganic substance, okay, having a definite atomic structure. Each mineral has a definite atomic structure. Each group has a definite atomic structure. A definite crystal system. We have 7 crystal system, and you take any mineral, it is crystallized in a definite crystal system. And a definite chemical composition. Each mineral has a definite chemical composition, like SiO2, silica, CaCO3, calcium, calcite. Likewise, we have different minerals with different chemical compositions.
सर तुम्ही म्यूट झालाय.
Yeah. Even today we use rocks, minerals, okay, for decorations, for weapons, or making. Even your you grind your seeds. दळाची पीठ दळायची गिरणीमध्ये तुम्ही बघितला खोलून तर आत दगड असतो, ग्रनाइट. Okay, 2 plates of rocks which move, okay, and that is the way the grains are ground and you'll have the powder, atta. Okay, so rocks and minerals are our age-old sathi, or our what you call amche sathi. Okay, they are used as ornaments also, jewelries. Now the minerals are classified by anions, that is oxides. They are silicates classified as sulfides. They are classified as halides, phosphates, using anions. They can be classified as internal with the help of internal crystal structures. Okay, name of the place where it has been identified, or where it has been picked up, or it has been picked up by whom, that is by person, and its chemistry. For example, we have atacamite after Chilean desert, smithsonite, then valastone, sillimanite. So these are the examples how the minerals are named after the people, or after the place of origin, or place of occurrence, or depending upon their chemistry. Minerals can be made up of elements. Single element minerals are also there, and we call them as native mineral. For example, we have gold. Gold is Au. Copper, not copper. Okay, gold, copper, Cu. Then Hg, mercury, platinum. These are all native minerals. Okay, which are made up of only one element. We have compounds. Many minerals we find they are in compound form. That is mixture of 2 or more elements. Okay, and in a fixed ratio they are available, and most minerals are compounds what we see today. there are more than 40,000 minerals available. Okay, and every day there are new minerals added. And following is the just gist of whatever different minerals we have on the earth crust. Okay, we have native elements, that's about 50. Okay, then there are sulfides and other ides, sulfides, ammonites, etc. There are 300. Oxides, they are about 250. There are many. You can go through the list. Silicates are maximum 500. Then we have these three groups: phosphates, arsenates, and vanadates. They make 350. Okay. So first highest we find minerals in the form of silicates. Then we have oxides, sulfides. Usually sulfides are ore minerals. We'll discuss what is ore mineral and what is the mineral. Oxides, etc. Now native elements, example sulfur, gold, diamond, graphite, etc. They are native, including copper. Then sulfides, we have pyrite, galena, okay, with the help of these chemical formulas. Oxides, hematite, magnetite, halides, sulfates, carbonates, phosphates, silicates, etc. Okay. So native minerals are those found in their pure state in nature. Okay, gold you can find out in the native form. Directly you can use them for without any processing, like silver, platinum, copper. Okay. Compound minerals are those made up from combining more than one element. We have silicates, oxides, sulfides, etc. Why gold is so important? Why platinum is so important? Why silver is so important? Because they are not available freely. They are very rare. Okay, the abundance is less. For example, silica and other we find abundant. Okay, there's a joke in this thing we can go through. Isn't it stupid that the world economy is based on gold? You know all the importance of gold. Today's market is about 50,000, 48 to 50,000. Okay, isn't it stupid that the world economy is based on gold? Yeah, no matter how advanced civilization gets, we still use rocks for money. The dumb part is using a rock that's so hard to find. Okay, you don't find gold, platinum, etc. easily, diamonds, etc. easily. Now there are minerals, we call them as isomorphic minerals. Isomorphic minerals, minerals having the same crystalline form. This, even though the minerals have same crystalline form, but the shape and the structure, their use, it is different. Diamond and graphite are the example. Both are carbon. Okay, chemical composition is carbon. Diamond is very hard, soft. Graphite is very soft. Okay, but the origin is different. Okay, diamonds are formed at the deeper level. There are polymorphic minerals. Okay, they, even though the composition is same, but the forms are different. CaCO3 is the composition, but see the calcite mineralization is different. Aragonite mineral is different. Okay. So minerals are classified on their external form. Okay, we classify minerals into different systems. We have about 7 crystal systems based on the atomic structure and the packing. Okay, we have cubic system. We have, it is called as isometric, orthorhombic, triclinic, monoclinic, trigonal, hexagonal, tetragonal, etc. So each mineral will definitely crystallize in one or the other form among these. Economically important metal concentrations in earth crust, you should know this. Okay, in the earth crust we have abundance of aluminum about 8% by weight, iron 5.8, and others are less than 1. See the gold is 0.000002. Okay, that's why it is very rare and very precious. Similarly, our body is also called as mini earth. Okay, earth is composed of 70% of water and 30% land. Similarly, our body is also composed of 62% of water and other minerals. The rest are other minerals. Again, whatever we see on the earth crust, the mineral components, we find them in our body also. So we are part of our earth. Okay. Our earth resources, you see any country's economy depends upon the minerals. The minerals, mineral resources, metal resources, the country's economy depends upon the mineral resources. Okay. We have metallic, semi-metallic elements. We have non-metallic elements, gemstones, industrial minerals, construction and manufacturing minerals, fertilizers, chemicals, and energy resources like coal, oil, gas, etc. So these are non-renewable. All these minerals are non-renewable. That is, you cannot prepare them. You cannot use them like wind and water, solar energy. You cannot reuse them. Once you use, they are gone. So we have to use the mineral resources judiciously. What is mineral? It is already, I have discussed. It's a solid, naturally occurring inorganic compound having a definite chemical composition, definite crystal system, and a definite atomic structure. We have quartz, silica, calcite, many other minerals. There are 40,000 and odd minerals. Now, ore. Ore is also a mineral, but from the mineral, we exploit metal or non-metal from these minerals economically. Okay, the mineral which gives us metal or non-metal economically exploitable, or which is useful for economy of the country, they are called as ore. Similarly, ore deposit. Okay, so we have example bauxite, which produces alumina, which gives us aluminium, hematite, which gives us iron. Okay, likewise, varieties of minerals are there which produce metals. Now, how these mineralization takes place, especially whenever there is a magma intrudes, the surrounding rocks get affected because of temperature, and already existing minerals, the minerals concentrate because of temperature, pressure, etc., and the fluids add to with them and they produce new minerals. So alteration of rock by intrusion of magma these concentrate the elements. These elements gives up formation of minerals. The heat and pressure force out the impurities. Sometimes the pressure and temperature, whatever impurities are thrown out, only the concentrate of minerals, metals are deposited. So there are varieties of processes. Sedimentary process where chemical precipitation takes place. Okay, weathering, sedimentation, etc. in aqueous media, the solution brought by rivers in the oceans, and these solutes sometimes get precipitated in the ocean, giving rise to carbonates, especially limestone, dolomite, phosphates, etc. They are formed as a precipitate. So water with high concentration of element is evaporated to give rise to evaporate deposits like salts, gypsum, rock salt, many other salts, selenite, etc. Evaporation of water leaves the elements, giving rise to formation of salts. Even iron also is formed, especially we call as bog iron. They are even formed at the backwaters, hot brines they are called. The precipitation of calcium carbonate gives us formation of limestones. This is again in the Turkey. Many people go there as a tourist, and these are natural bathtubs. Okay, the water is rich with calcium. Many people go there for skin diseases, curing, etc. Evaporite deposits occur when shallow marine basins or lakes dry up and dissolved minerals solidify. The concentrate which is left after drying, that produces salts. Okay, we find huge salt deposits, especially in Afghanistan and Pakistan area. We find such rock salts, what we use daily for our cooking and as edible salt. You can see this is brine, backwater, which is again evaporite. So many evaporites like borates. This is again sheets of salts you can see. So processes that concentrate elements, the processes are igneous processes. Under that we have hydrothermal processes where effect of temperature and water is effective. There are magmatic processes where magma gives rise to minerals. Again, early magmatic and late magmatic, etc. Sedimentary processes we have discussed just now, carbonate deposits. Mechanical sediments gives rise to placer minerals. Chemical deposits gives rise to carbonates and magnesium deposits like limestone, dolomites. Biochemical processes gives rise to fossiliferous limestones. Many carbonates which are rich with micrite, etc. Okay. Animal skeleton mixed rocks. Then metamorphic processes produces minerals. Then groundwater processes also produce minerals like karst topography, effect of water on the carbonate rocks. So igneous rocks are formed due to volcanic eruptions, magma, etc. Okay, I think you all know volcanic eruptions, lava flows. Okay, these are some examples. So whenever magma, before consolidating, it consolidates. Density stratification takes place. The high density minerals form first at the bottom, then the low density go or rise above and they crystallize. So whenever we find at the bottom high density minerals and at the top we have low density minerals. Now crystallization takes place in cavities. Okay, whenever there is a igneous eruption, if there are any cavities, these cavities are filled by secondary minerals. Okay, and these secondary minerals usually are very important as zeolites. Okay, they are used as decoratives or as a filter units for minerals, oils, and water, and even petroleum. They use zeolites as filters. You can see this is basaltic rock. We have amethyst as a cavity filling mineral. Amethyst is again used as gemstone, semi-precious stone, okay, because of its purple color. You can see this is a zeolite, huge cavity, and Pune people you all know Makki. He is one of the one famous geologist, come trader, mineral lover. He has huge collections, and I'm happy to inform you that he has donated a lot of minerals to our department to develop our museum. Okay, these cavities are filled up by secondary minerals. Depending upon the solution content, the elemental content, minerals are formed, the colors of the minerals are formed, the shape of the minerals form, the crystallization. Okay, they are very beautiful to look at. You can see they're like almost coconuts. He's Sri Makki and he's his son Sam Makki. They are into zeolites. Okay. Huge cavities covered with zeolites. Varieties of wonderful zeolites. There are huge cavities below ground. Okay, especially in basaltic area. All over Maharashtra, we have cavities, smaller to bigger cavities, which are filled with minerals. Now, this one is below Mexico, about 8 kilometers underground. And this one is huge one, 9 kilometers width and length. Okay. I'll share one of the video. I hope you can see this video.
Yes, sir. दिसतंय.
Yeah. This is one of the huge cavity. The minerals are almost 4 tons. Each mineral is about 4 tons.
Some crystals are 11 meters long, weighing 55 tons. They're as high as telegraph poles. You know what's amazing? All of these crystals are formed.
See the cave.
The team starts to soar. Beyond it,
Hope you remember Superman's first
bright pillar-like
entry.
they descend to the center of the cave, where there is a deep depression and the best view of the entire cavern.
The mineral is selenite, a variety of calcite.
Their right is a sheer crystal peak. At its top is a tiny passageway to their main. The 2018 discovered a vast yet leads to another crystal cave.
Yeah. That was wonderful cave recently discovered, and it is below Earth about 8 kilometers. The mineral, they say there was a huge cave which was covered with a lot of solution, which is rich with selenite, and these crystals were crystallized thousands and thousands of years they took for crystallization, and each crystal is weighing about 5 to 6 tons, and about length is about 3-story building. Imagine the beautiful nature. Minerals are formed by hot water springs, geysers, especially sulfur, the native element. Okay, sulfur rich with volcanic activity, especially Indonesia, Africa, and other countries, even Yellowstone National Park. These are hot water springs, geysers they're called. Very hot water, but rich in sulfur. And this sulfur mineral is mined, and these minerals are used for curing skin diseases. They use them for preparation of medicines, etc. Okay. What is ore, grade, or tenor? Ore grade is the concentration of economic mineral or metal in the ore deposits. Tenor, okay, tenor is percentage of metal content in the ore. Okay. Now weight percentage for base metals. Now for gold and all, we'll not measure them into kilos, so okay, tons and all. Usually when we buy them in ounce, okay, or grams. Now these are the indication of ore bodies inside the ground. The color, the texture of rocks provide clues for us to understand what minerals are there inside. And the texture of this network-like texture, the color greenish indicates copper mineralization, etc. Okay. So many, including even biological indicators like botanical indicators are also there. Some plants provide clues like your curry patta. Curry patta, if you have maximum growth or widespread availability of curry patta, indicates again copper deposit. So minerals are classified based on genesis of ore deposits. Internal, they are called as endogenic, When the minerals are formed inside, they are called as endogenic, and if they are formed on the surface, they are called as exogenic. Endogenic, exogenic, internal and external, on the basis of their time of formation relative to rock, whether the minerals are formed during the formation of rock itself or whether the minerals are formed after the rock itself. Okay, they are called as syngenetic. Syn means at the same place. Epigenetic, after. In another common method of classification, we classify into hypogene or primary deposits and supergene or secondary deposits. Primary deposits when they are affected by oxidation, reduction, and chemical leaching, and the minerals are leached to a level of groundwater where they are concentrated into pure form, especially the native elements, gold, etc., are formed at the supergene enrichment, even bauxite. Okay, and these are the variety of ore minerals. We have galena, lead, cinnabar, mercury, pyrite, iron sulfide, sphalerite. So these are ore minerals from which we find metals. Okay, so they are economically important minerals. Some minerals occur together, like copper, gold, silver, or lead and zinc, arsenic, cinnabar. Some minerals, they occur together. These are some minerals, garnet. There are clay minerals which are identified in the microscope. Oxides, they are resistant to further chemical attack and generally form strong hard minerals, especially iron formations, hematite, magnetite, which are used for extraction of iron to make steel. We have native elements already discussed: platinum, mercury, silver, gold, carbon, sulfur. We have sulfides, which are compound minerals. Chief ores are copper, zinc, nickel, molybdenum, etc. Then we have halides, especially salts, rock salt, including gypsum and selenite, etc. Phosphates, usually we use rock phosphate, etc. for fertilizers, agriculture.
सर सॉरी मध्ये डिस्टर्ब करतोय. एका
हा, सर.
पार्टिसिपंट्सला मागची स्लाइड बघायची होती परत.
हलाइड्स
येस
कुठला सर?
येस सर.
Okay. Sulfides, halides. Usually halides are evaporite deposits. Phosphates usually occur under ocean. Okay. Sometimes minerals like apatite are found in granites. Now, underwater, effect of groundwater. When the water affects on the carbonate rocks melt or dissolve, giving rise to variety of structures. These are beautiful structures which we use as geotourism spots. Even in India, we have Meghalaya, Andhra Pradesh, we have, even in Karnataka, Ulvi, we have many caves. Okay, these caves are important for mineralization, especially calcite and other minerals. These structures are called as stalactites and stalagmites. Okay. Now you can see these balls. These are all formed in the caves. They are called as calcareous pearls. Now minerals are formed due to metamorphic activity also, that is because of direction of stress, effect of temperature, pressure, and direction of stress. Produce the pre-existing minerals get affected, remodify the mineralization, texture, etc. They give rise to new minerals. Especially these minerals from metamorphic rocks are hard. Especially the gemstones, semi-precious stones are found from the metamorphic rocks. Garnets and other minerals. So metamorphism and metasomatism. Metasomatism is again additional force and temperature, etc., to metamorphic rocks. So we identify the minerals based on the physical properties. Okay, physical properties of minerals are very important for any geologist to identify the minerals. Okay, so we call these properties as physical properties of minerals to study the hand specimens. There are three important aspects, and fourth one is other properties. These three are very important, and I'll not be going in detail, but just highlight properties depending upon light, that is effect of light on the mineral, how the light affects on the mineral and how we see the mineral, especially the color. Various colors of the minerals are one of the important parameter. Streak, that is if you rub the mineral on a streak plate, porcelain plate, the color of the mineral left on the streak is different than the main color of the rock mineral. Okay. Luster, how the mineral shines, diaphanity, the transparency of the mineral. Then properties depending upon state of aggregation, how the form is there, how the minerals are columns, whether they are laminated, thin sheets, granular grains, imitative shapes, whether they are botryoidal, potato-like, amygdaloidal, cavity fillings, vesicular, and stalactitic. Properties depending upon cohesion and cleavage. These are the fine fractures, like where the mineral splits along that cleavage easily, and these cleavages are almost equally spaced. Each mineral has a definite cleavage pattern, whether it is one single cleavage or two cleavages or three sets, one set, two set, three sets, etc. Fracture, how the mineral looks after breaking, whether the plane is flat, whether it is conchoidal, whether it is rough. Hardness, to measure hardness, we have Walker-Stillard balance. With the help of that, we identify the hardness. Hardness is Mohs hardness scale. For specific gravity, we use Mohs Walker-Stillard balance. And tenacity, how the mineral behaves with the pressure or hammering. No, minerals are, you must
sir,
have
sorry,
observed.
sir. Please again show earlier slide.
This one?
No, earlier. Earlier to this. Yeah.
Okay, sir.
Okay, sir.
That's
Thank
the
you.
effect. Okay. So minerals are also observed like flowers, in the form of flowers. Many a times we find these minerals, they imitate some flowers. You can see those, and definitely you will come one of the flower in front of you. Okay, similar ones. These are all minerals, rhodochrosite and other minerals. Albert Einstein had said once, look deep into nature and then you will understand everything better. So nature is wonderful. So God geometrizes continually. Plato has said in 427-347 BC. The sequence begins from 0, 1, 1, 2, 3, up to 34, up to 55, and so on forever, and has fascinated many mathematicians, scientists, designers, and artists for centuries. Leonardo da Vinci has shown the use of Fibonacci sequence in his masterpieces, and these figures, okay, flowers, have shown some definite geometry. Okay. Similarly, the minerals also follow a definite geometry. Okay, I'll show many photographs of minerals which also show definite patterns. Okay, almost like rose. You can see so many minerals, they almost imitate one or the other flowers. Now this is left side we have natural flower, right side we have calcite flower. This is flower formed by ice, cooling of ice. Okay, flower of ice. Now these both are calcite flowers. This is also calcite flower like lotus. You can see in a cave they are crystallizing in the form of flowers. This is like lemon. This is apophyllite, very native of your Pune. Makki sir has dug out many such minerals and they have published in international journals. So scolecite, again native of your Maharashtra. Rhodochrosite, calcite. See this one. This again imitates aloe vera. This is misolite, again from Makki's collection. This is natural tree. These are natural flowers. Okay. So nature follows geometry. Now left side we have calcite.
Sorry, sir. Again disturbing you. People
Yeah.
are interested to see all the beautiful minerals slowly.
Okay.
The
Okay.
flowers and all the arrangements which you are showing.
Okay, sir. Should I go back?
Yeah.
I was just worried because whether I should continue up to 8 or 8:30. So I was a little hurry.
Okay.
Okay, sir.
Yeah, sir. Sir, one question is, are they hard or brittle?
They are brittle, they are hard. Now this one is pyrite, golden color. This is very hard. This one is again copper. It is hard. These are all software ones. Okay, brittle. Calcite. This is also brittle. Soft. Now this is apophyllite. If you keep it long time in exposed to light, the color fades. It will become light. But if you keep in shadows or in within before sunlight, okay, avoiding sunlight, you'll retain the color.
Sir, is it possible to give us information about the location? Means not exactly, but in which area we can find this?
This is, I think,
For all the samples.
all the I don't remember, sir, but
Okay,
I have
okay.
collected from internet and all.
Which were at which anyway when you can remember, please tell us.
Yeah, yes. These are all from western our basaltic terrain, that is our Deccan basalts from Pune to Nagpur and Nashik, those regions. This apophyllite and even the blue cavensite, blue color is from Pune. This is from Pune, Ahmednagar district, Sangamner. The sample is from Sangamner, but we find in Pune also. These are international ones, rhodochrosite. These are all rhodochrosite, copper minerals. Many of them I have downloaded from internet, sir. Whenever I find some interesting figures following some flowers, I have collected. The blue color is cavensite. This is again from Pune, I think, from misolite, from Makki's collection. You can visit to Makki's collection. He has a very good collection. Blue color is azurite, copper mineral. Yeah. Yes.
Yes, sir.
Yeah. Somebody wanted to ask something or?
No.
So I'm just showing the natural trees and flowers now, and all whatever I have shown, they definitely follow these patterns. Okay. Now, this left side is a natural calcite mineral with pyrites. Okay. And right side we have the garden plant. Everybody knows this plant. So almost same pattern. The scientists have earlier also they have informed that these flowers, minerals, they follow some geometry. Okay, this is one by Leonardo Pisano's discovery, Fibonacci spiral. Okay, especially the ammonite coiling. Okay, here is given here number also 1, 3, 5, 8, 13, 34, 55 like that. And we definitely see all these given pictures, they follow these geometry, including the our galaxy, okay, sunflower, including cyclone, including the runners, plants, our finger prints, our hair grows in circular pattern. These are animal shells. These are goats' tusks. See the pattern, almost they follow definite pattern. These are natural accumulation of shells. Now minerals are identified with the help of hardness scale. We have 10 minerals starting from talc, which is very soft, up to diamond. Okay, they go on rubbing the minerals, the known minerals to unknown minerals, and when the known mineral scratches the unknown mineral, that is the hardness of that rock. Likewise, we identify minerals. Okay, this is one of the physical property to identify the mineral. This is specific gravity identification. This is called Walker-Stillard balance. Again, they use weight in the water, weight in the air, and substitute, giving a formula that gives specific gravity. Each mineral has a definite specific gravity, and using that specific gravity, people identify minerals. Now, other properties also are there, like reaction to acids, hydrochloric acid, even urine, etc. Some minerals like calcite, calcareous minerals, they get affected by these acids. Some minerals are identified by taste, like salt. Okay. Some minerals are identified with the help of feel, like talc. Talc is very soft. We feel soapy. Graphite is greasy. Likewise, we have magnetism. If you put a magnet near a mineral, it can attract, and that mineral is magnetite. Now we use even flame tests to identify some unknown minerals. Okay, so all these properties are used to identify the minerals. Okay, this is how minerals are tested using acids. If it gives effervescence, definitely it's a carbonate rock, limestone, dolomite, etc. So you can see magnet, it attracts steel or iron, okay, or it deflects the magnet north, magnetic north. Now gemstones are one of the important Minerals for mankind. We use gemstones definitely. It's a proud feeling for any woman to use gemstones, jewelries. A gemstone in general is a stone that is beautiful, clear, that is transparent, rare. They are found very rare. So they are called gemstones and they are expensive. They are durable. The hardness is more than 7. Others are too common and are given a semi-precious status, such as agate, chert. Okay, many are there. They are even amethyst. Many silicates, especially with the hardness 7 and above, the 6 and above are called as semi-precious. 7 and above are called as precious, like topaz and other corundum, ruby, etc. They have high index of refraction. When they polish, they give sparkling like diamond. Most gems are silicates, which can be very stable, hard minerals. A few gems are oxides, and only one gem, diamond, is composed of carbon, single element. There are few gemstones are called mineraloids, especially sometimes they are also called opal and amber. Amber is a gum converted to mineral. Tree gum, which is deposited under sediment and converted to fossil, amber fossil. Okay. While almost any mineral can be cut in the manner of a gemstone, without cutting and giving a shape, they cannot be called, they cannot be priced. Okay. The natural diamond, if you go to market, doesn't have value. But if you cut and give a shape, brilliant shape, then the refractivity, etc., then the value increases. Now people are preparing in the laboratory also. They are called as synthetic gems. What we find American diamonds and many other diamonds, they are synthetic. Gemstones in the elements class, we have diamonds, gemstones in oxides, we have corundum, ruby, sapphire, and many other varieties of gemstones are there. Red one is corundum, hardness 9, brilliant reddish color, crimson reddish color. Then we have silicates, varieties of silicates in the form of gemstones. Under that we have beryl, again green color, blue color. We have aquamarine blue, emerald green color. Okay, so varieties of beryls are precious stones. We have garnets, varieties of garnets, almandine and andradite. We have green garnet, red garnets, yellow garnets. Okay. Then we have jades, green color jades. We have peridotite. We have quartz variety, semi-precious stones, amethyst, citrine, tiger's eye, and other smoky quartz. Then this is amber. Okay, amber is again a precious gemstone, and the price increases with the insects inside, the type of insects inside, the clarity of the insects, etc. The price increases. Okay, these are called as ambers. These are pearls. Pearls again precious. They are formed by organisms in shells, bivalves. Now these are also prepared in by man in laboratories. They are culturing. Now these minerals are used for creating sculptures. Only the mineral may not fetch you the price, but when they are carved into some shapes, they are highly prized. Okay, for example, you can see this agate, amethyst. Okay, we have azurite. again amethyst, agates. There can be huge zeolites. Okay, you can see these zeolites, amethyst. Varieties of sculptures, rose gods. Now there can be exhibitions, especially these are from photos are taken from Makki's collection. He goes to many countries to exhibit his collection along with others, and he sells also. So we have varieties of minerals exhibited. People collect them by giving prices. You see, this is China market of minerals. Likewise, America and others, they have lots of such exhibitions come sales. But unfortunately, India doesn't have such huge market. Indians, they doesn't give much importance to minerals. So now we'll discuss about uses of some important minerals. Now calcium, limestone is used as a calcium. These are sedimentary rocks formed by chemical reactions, chemical process. They are also derived from shells of animals, bivalves, organisms. They are used in making calcium tablets, widely used in medicines, cosmetics, toothpaste, etc. They are also used as abrasives. Fluoride, again, fluoride, if it is increases in your water, you will get disease, fluorosis. And if it is less in your body, you will have again difficulty in teeth problems. So we use calcium fluoride in your paste. So it's a common mineral deposit of formed due to hydrothermal origin. Okay. If the water contains more than 0.7 to 1.5 milligram per liter, it is hazardous. You will cause fluorosis. The teeth and bones will decay. Many places in Karnataka, northwestern Karnataka, we have these diseases. The pollution is there, a lot of fluoride pollution, because the rocks here are granites with apatite and other minerals. Then mica is again hydrous potassium aluminum silicate. Mica, we have two types, muscovite and biotite. These flakes, muscovite flakes, are used as anti-electric. Okay, it doesn't allow electricity to pass. So if you have seen your electric istri, it has a flake of mica. Okay, so they are very flaky, silky in appearance. They occur mainly by igneous activity and metamorphic activity. And India has the largest mica deposit, especially in Jharkhand and other Andhra Pradesh. The Ayurvedic people use as a medicine, preparation of medicine for respiratory disorders, liver and abdominal diseases. Clay minerals are used for cosmetic purposes because of its soft nature. Usually white clay and red clays, black clays, varieties of colors we find, and these are derived from feldspar minerals especially, and basaltic rocks. Kaolinite clay occurs in abundance in soils that are formed from the chemical weathering of rocks in hot, moist climates like tropical climate of Western Ghats. They are used traditionally for preparation of body absorbs calcium more efficiently. Taramine, face packs, especially in parlors, beauty parlors, they use packs, face packs. Many people use crystals for healing purpose, and semi-precious, precious stones for they use as a healing. Okay, different uh, what you call different. We have Libra, Dhanush, Kumbha. We have 9 aspects. For each one, we have different minerals. People buy them for creating positive energy or crystal healing energy, etc. And most of these Egyptians, even in India, we use these minerals as healing powers. Especially Pachu people ask, okay, diamonds, etc. So they deal with the flow of positive energy through crystal into the body. Many scientists and doctors doesn't believe this, but many people, old people, they believe in this. In crystal healing, stones are assigned various properties, though healers have different ideas about which stones possess what properties. Amethyst is used, green aventurine is used for heart, yellow topaz for mental clarity. So minerals are used for positive energy also. There are poisonous minerals also. We should be very careful about these minerals. These are the 10 deadly minerals. Like we have deadly snakes, we have deadly minerals also, which are highly poisonous. Okay. The mineral chalantite, hydrated copper sulfate. This is the mineral. The copper in this mineral is exceptionally bioaccessible. Okay, it dissolves in your body and is lethal to plants and in high amounts dangerous to people. Okay. Hutchinsonite is sulfur salt mineral of thallium, arsenic and lead it contains. It is unsafe and is an uncommon sulfur salt mineral. Important aspect here is it can bring about male pattern baldness. Okay, if anybody has this infection, male pattern baldness, like Nehru and Gandhi, the baldness will happen. Then galena, lead mineral, lead sulfide. Again, earlier people, we used to bind the pipes using lead, but now they have been banned because they were polluting the water with lead. Okay. So lead doesn't get flushed out of our health framework. It aggregates throughout the years. It goes on concentrating in our body throughout the year. In the long run, it gives harmful levels. When that happens, both you and your children, maybe generations, pay the cost, as lead is dangerous and is causing cancer. Okay. Then cinnabar, mercury. Mercury, as you all know, it is highly hazardous. Okay, damages to the sensory systems of kids. It is dangerous in little fixations and can be consumed through the respiratory tract, entrails, or skin. Asbestos is not one mineral, but rather 6 characterized separate minerals, one being serpentine. There are varieties of minerals which contain asbestos fibers, and they create respiratory problems. Stibnite, again, is a highly dangerous mineral, which the sharp grain stings can cause poisoning. Hydroxyapatite is a calcium apatite, will store on your heart walls, viably petrifying them. Petrifying is hardening the heart walls. So this is also very dangerous mineral. Phenacite, okay, tuberculosis. Okay. These are varieties of gemstones. Now diamonds. So minerals are found under, can be seen beautifully under microscope also. You can see those fine minerals, including organic materials, shells, shell fragments. So we study minerals under microscope. You can see varieties of minerals. This is our geology museum in our department. Okay, and which are being donated by Makki sir. These all big specimens of zeolites. Okay. So this is one of the best museum in Karnataka. Now many people visited our department. If you all are coming to Belgaum, please visit our department. Thank you. Thank you, sir.
Thank you very much, sir.
Thank you, sir.
आपण आता क्वेश्चनेअर कडे वळू, पण त्या सेशनला वळण्याच्या आधी मी सरांचे आभार मानतो. थँक्यू व्हेरी मच सर की तुम्ही आम्हाला मिनरल्स खूप सुंदर माहिती दिली. त्यातले काही सुंदर प्रकार दाखवले, पण त्याचबरोबर डेंजरस काही स्पेसिमेन पण दाखवले. मिनरल्सचे आपल्याला काय काय उपयोग आहेत हे पण तुम्ही शेअर केलं होतं. त्याबद्दल सर तुमचे खूप आभार. सर्व पार्टिसिपंट्स आणखी जीवितातर्फे तुमचे आभार मानतो. थँक्यू व्हेरी मच सर.
थँक्यू सर. थँक्यू.
आपण क्वेश्चनेअर विचारण्याच्या आधी दोन गोष्टी शेअर करायच्या होत्या की सरांनी जे दाखवलं, मक्की सरांचं खूप वेळा उल्लेख झाला. तर जीविदाच्या अर्थ सायन्स वीकच्या सुरुवातीचं पहिलं प्रदर्शन मक्की सरांचंच घेतलं होतं आणि घोले रोडला आपण ते प्रदर्शन घेतलं होतं 4 वर्षापूर्वी.
अरे वा.
तर रिस्पॉन्स मिळाला आणि तिथपासूनच आमचा अर्थ सायन्स वीक मध्ये प्रदर्शनाचा सिलसिला चालू झाला असं मी म्हणेन. दुसरं सरांनी मिनरल्सचे खूप उपयोग सांगितले. आणखीन 2 वर्षापूर्वी जीविदातर्फे माणसांनी दगडाचा केलेला वापर असा एक या विषयावर पण प्रदर्शन केलं होतं. त्यालाही खूप सुंदर रिस्पॉन्स मिळाला होता. तर त्याच्या मेमरीज तुम्ही आमच्या खूप जागे केल्या त्या सर्व माहिती सांगून. सो त्याच्याबद्दल अगेन थँक्यू. उद्याच्या बद्दल सूचना की उद्या आपल्या या व्याख्यानमालेचं 3रं लेक्चर आहे आणि विषय असणार आहे प्रस्तरातील मानवनिर्मित स्थापत्य म्हणजे आर्किटेक्चर इन स्टोन बाय ह्युमन. तर त्याच्यामध्ये डॉक्टर मंजिरी भालेराव मॅडम उद्याचं लेक्चर घेणार आहेत. टिळक महाविद्यालयामध्ये मॅडम शिकवतात आणि मुख्यतः भारतामध्ये वेगवेगळ्या प्रकारे दगडाचा म्हणजे वेगवेगळ्या प्रकारचा उपयोग दगडांचा याच्यात कसा केला, त्यात मुख्यतः मंदिर असेल, मूर्तिकला असेल, आणखी लेणी असतील, तर या विषयावरती मॅडम बोलणार आहेत. ज्यांना खूप इंटरेस्टिंग असणार आहे. आणखीन त्यांच्या या नॉलेजचा उपयोग करून घ्या. त्याची लिंक मी आधी पाठवलेली आहे, तर प्लीज चॅट बॉक्स मध्ये ती लिंक बघा आणि त्यानुसार जॉईन व्हा. मी आपल्या ग्रुपवर तर टाकणारच आहे, पण ते तुम्हाला आता ती रेडी सुद्धा मिळेल. सो थँक्यू व्हेरी मच. तुमच्या सगळ्यांचे आभार. नाऊ स्टार्ट द क्वेश्चन्स. प्लीज एकेकाने अनम्यूट करून प्रश्न विचारा. त्याच्या आधी चॅट बॉक्स मध्ये सर 2 प्रश्न होते. सर ते पॉइझनचं मटेरियल नक्की काय प्रकारे असतं आणि हार्मफुल कशा आपल्याला खूप प्रकारे करतं का?
मिनरल्स सर, आता जे काय मी 10 मिनरल दाखवलं ना, ते सपोज टच झाला किंवा डिझॉल्व्ह होऊन आपल्या अंगात गेला, बॉडीमध्ये शिरला, तर त्याचा परिणाम होऊ शकतो. लाईक फ्लोराइड इज अ कॉमन मिनरल विच अफेक्ट्स आवर बॉडी. लिमिटेड क्वांटिटी मध्ये असेल तर काय प्रॉब्लेम नाही आहे. थोडं इन्क्रीज झालं दॅट विल बी डेंजरस.
ओके, थँक्यू सर. आणि अजून एक प्रश्न होता, विच मिनरल्स आर फाउंड मोस्टली इन द पोरस रॉक्स?
ऑल zeolites sir, secondary minerals.
ओके, थँक्यू. आता बाकीच्यांनी प्रश्न विचारायला हरकत नाही.
Sir, can I ask one question?
Yes sir. Yes sir.
I wanted to know what is the exact difference between calcite and calcium carbonate.
Calcite,
is there any difference?
Yeah. Calcium carbonate is a compound sir, like calcite is a mineral.
Okay.
General term calcium carbonate. All carbonate minerals are involved in that.
But the formula for both is the same.
CaCO3.
CaCO3.
Yeah.
Achha. अच्छा अच्छा अच्छा. Okay. Thank you. Thank you. Thank you.
Sir, I wanted to ask that where are these toxic minerals found?
These minerals, like now in granitic terrain, if you go, you can find fluoride. In volcanic terrain, volcanic eruptions are there. Then we find sulfur, arsenic. Arsenic is also poisonous. Okay. Likewise, including some zeolites, also you find some minerals like copper. Copper is also sometimes, if it adds more than the required, then it can be poisonous. Lead. Now, lead we find in Udaipur district, Jawar mines. So around Jawar, the water can be poisonous. Okay, because the Jawar mine is having huge deposits of lead and zinc, and these water, when they affect these minerals, when they come in contact with these minerals, these water can be polluted, and if we consume that water, that will affect our body.
Okay, sir. Thank you.
Thank you.
So there is one more question in the chat box from
Yeah.
Amod that he want to know. I have some rock collected from the Himalayas.
Okay.
They do look like mica. Is
Yeah.
mica available in these areas?
Yes, yes. In Himalayas also we find, because before Himalayas they were Asian rocks. Okay, then we had Sea of Tethys that had lot of sediments. When Indian plate collided, some portion of India also got, that is peninsular India. We had Precambrian rocks, and those rocks also had mica. So we find mica in Himalayas also.
Okay, thank you very much, sir. There is one more question from Mrinal Vaidya.
Yeah.
She's asking that copper sulfate crystals are blue and
Yeah.
the metal has reddish metallic color. How so?
There are many other, like many minerals are reddish in color. There are 5 minerals. Okay, chalcopyrite, yellow color; rhodonite, we have rhodochrosite, reddish in color. Our azurite is blue. Then we have green color, malachite. So that depends upon the concentration and elemental concentration.
But she want to know that copper sulfide crystals are blue, but in metal we found it in reddish color. So why this difference is there?
That
In
is
metal
processing. When we even chalcopyrite, when we process malachite is green color, but when we process, it will have a reddish color, metallic. Okay, the metal content, metal color itself is reddish color, crimson reddish color, copper red we call. The primary color of copper is reddish. Okay. Native minerals like gold, even if you process it, will remain yellow only. But these copper minerals, they are oxides, sulfates, etc. They are not native. But native copper, you have copper color only.
Okay, thank you very much, sir. There is one more question. Are minerals collected from different location which are far away from each other look exactly same?
Yeah. Because the mineral in which they crystallize, they have to obey the crystal system, the atomic structure, the chemical composition. If it is same, they have the same feature. Okay, form, their crystal form or shape, etc. will be same. If it undergoes weathering and chemical action, then the shape and other color, etc. changes.
Okay, thank you very much, sir. There is one more question, sir. We have collected of collection of rock. We cannot find out the names. How we can find it? Because so many times they look same.
Yeah, that is many a times people get confused because they don't have knowledge of geology and types of rocks, minerals, etc. But you need to contact some geologists so that it will be easy to identify. Otherwise, you can send pictures, close pictures. We can try to identify them.
So, adding to this, is there any field guide like thing to identify for identification?
Yeah. There are many. They can Google them. They can give colored pictures, including tests, what tests they can take up to identify, etc. There are many.
Okay, thank you very much, sir.
Thank you, sir.
So, is there any more questions from your side, participants? काही प्रश्न आहेत का? Okay.
Hope people enjoyed this presentation and minerals.
कार्लेकर सर, तुम्ही काही एंडला सांगू बोला?
नाही म्हणजे व्हेरी गुड ऍडिशन टू अवर नॉलेज ऑफ मिनरल्स. खूपच चांगली माहिती मिळाली.
Thank you, sir. I thank once again Karlekar sir and Pandit sir for giving me this opportunity.
हो, थँक्यू व्हेरी मच सर. प्रमोद सर, खूपच सुंदर माहिती मिळाली आम्हाला. थँक्यू व्हेरी मच. सर्व पार्टिसिपंट्सचे आभार. सो एंड करताना मी म्हणेन की स्टे होम, स्टे सेफ, गुड नाईट. याबरोबरच आपण आजचं लेक्चर संपवतो आहोत. आजचं सेशन उद्या मी मगाशी म्हटलं त्याप्रमाणे हिस्टॉरिकल टच असलेलं सेशन असणार आहे. तर त्यामुळे यू विल गेट व्हेरी डिफरंट अँगल. दगडाबद्दलचा खूप वेगळा अँगल आपल्याला बघायला मिळेल. सो उद्याही सगळेजण जॉईन व्हाल अशी मी आशा व्यक्त करतो. त्याचं परत एकदा सांगेन की तुमच्याबद्दलचं त्याची लिंक सोबत दिलेली आहे. सो थँक्यू, गुड नाईट.
थँक्यू प्रमोद सर. थँक्यू व्हेरी मच.
Thank you, sir. Thank you.
थँक्यू व्हेरी मच. थँक्यू व्हेरी
Good night, one and all.
Thank you, sir.
थँक्यू.
Good night. Thank you, sir.
Thank you, sir.